Today I share up the inner workings of the Ghostbusters ghost trap. Starting at the very end here, we've got a power switch to turn it on and off, LED for when the trap is full, and it's powered off two 18650 LiPo batteries. Now this is the same storage area where the e-cigarettes will go once they arrive. I'm still waiting for them to be shipped across, so hopefully they won't be too far away. The output from the LiPo batteries comes along here and goes to this UBEC, which is a battery eliminator circuit used in radio control gear. Basically drops the output from the two LiPo batteries, which is sort of between 7 and 8 volts, down to either 5 or 6 volts. So I've currently got the pin set here for 6 volts. Two kind of raw reasons. The Uno will take it quite happily. Also the pump here, which is used for the e-cigarettes to make the smoke effect when those arrive, that's 6 volts. And in the back there is a circuit there for the LED lights that was primarily designed for 12 volts but will run at less, so 6 volts is getting it closer, but certainly enough to drive the LEDs. Main control piece is an Arduino Uno board, cheap as chips. You can get loads of these off AliExpress for not much money. From here, I've got inputs. There's at the very back here, you can probably see the back end of a switch just there. There's basically a push button, which I'm using to trigger the trap to make it work. There is the LED, which I mentioned here. There's another LED at the top where it's full, and this bar graph. This bar graph is an Adafruit bar graph. It's bicolor, so effectively makes a total of 3 colors. Based off red and green, but it can make red, green, and orange with the two LED colors that it's got. That's connected to this board here. The actual bar graph pieces are designed to be surface mounted. There's 2 of them that come with a kit. I've only used 1 of them, and I've used ribbon cable to connect it from where it would be surface mounted up through here, up through where the 2 servos go to here. Now in here we have where the servos go. There are 2 servos. These are the Metal Gear ones, the MG90s or the SG90s are the, I guess, the plastic equivalents of it. There's a plastic chain that then drives the 2 door flaps here. So as they turn, there's a chain that goes up and around a cog, and that turns the little metal bar that's in here, and there's a little grub screw that screws into that to hold that in place. So as that rotates, that opens up the trap and exposes where the LEDs are. For music and sound, I'm using a thing called a DF player. Again, these are pretty cheap. You can get them for $3 or $4 off AliExpress. That basically runs off 2 pins for serial. So it's a communication over a serial port. Just needs a resistor for the serial port because it's designed for a 3.3 volt input, whereas the Uno is giving 5 volt output. So you just need to reduce that down just so the signal gets through. And it has a little SD card on it, which you can put your MP3s and you label them from 0001 to whatever number that you want to go up to, and it will play based on a track number. The output from the DF player is to the speaker here. So in this case, it's just a 4 ohm speaker. This is more than overkill for what it's running through, but it's 3 watts that it's got, which is more than enough for this type of activity. Nice small form factor. Doesn't use a whole lot of power, easy to use. Once you get up and running, yeah, it'll do all the effects that you want. Then the last board down here is a custom one that I've made. It basically takes the 6 volt input, creates a like a bus bar for the other devices to connect into, take the power from it. There's also a couple of transistors, one that can take a reasonable amount of current here, which is for there's 3 watt LEDs that run across here. So there's a reasonable amount of current that needs to be drawn, and I need a transistor that can handle that. So I've got one there for that, and then a cheapy 2N2222 transistor, which is enough to trigger this aquarium fish pump, which is a 6 volt. It's less than half an amp to run that at peak. So you're running a relatively low amperage across that, so that should be sufficient for it. Hasn't got hot or anything like that, so it doesn't look like it's going to burn out. The other call out I would say from some of the other designs that I've seen is just built in a voltage divider. So I've taken the voltage output from this from the LiPo batteries, and I've run it into here. created a voltage divider with a couple of resistors, and then I've got that outputted into the Arduino Uno. That allows me to have effectively a voltmeter just to check the status of the battery. So one of the first thing it does is when you power it on, it'll do a voltage check, and then based on how much voltage it gives me an indication on the bar graph of what the battery state is. So just kind of handy to know, is my battery running flat? So let's start her up. So it does a initialize. And that's the voltage check, so I can see in this case the battery's pretty full. Don't have to worry about it. And by this point, she's pretty much ready to go. So as mentioned, there's a push button that's on this other side. I'll try and turn it around a little bit. So there's a push button around here. This is what triggers the trap. So effectively I can press this. It runs the air pump, does the sound. And closes. Gives you the light. Bar graph full. Let you know that the ghost has been trapped. And you can press this one more time, and that resets the trap. There you go, that's how she works.